All right. Good morning, good afternoon, good evening. Welcome back to the Architecture Track, or welcome if this is the first time you're joining us here at Spring One. I am delighted to have a couple of our good friends from Microsoft with us. Now I'm old enough to remember when it was mildly controversial that the best laptop for developing .NET code was in fact a MacBook Pro, and it was seen as strange to see MacBook Pros in the Microsoft booth at an event. But Rory was telling us as we were getting ready here that he just got a brand new MacBook Pro. Although I'm a little worried, he was telling me he's got some rolling blackouts. So fingers crossed, the technical gremlins are with us. The beauty of doing these virtual events is we get folks from all over. So Rory's joining us from South Africa, Kylie's joining us from APJ, and so apologies for all the time zone issues here. I think Rohit and I were talking, we probably are crossing 6 different time zones here, something to that effect. So I'm very excited to see what kind of fun stuff our Microsoft friends are going to talk to us about with Spring Boot on the Azure platform. So Rory, Kylie, take it away, friends.
Thank you so much. Hi, everyone. I'm an advocate for Java for Microsoft.
I'm Kylie, and I work as a program manager, enabling more Java developers to bring their app to Azure.
Let's set the stage. Spring's flexible libraries are trusted by developers all over the world. From the latest SNCC report, a significant number, 50%, indicated Spring Boot as their framework of choice. Most of you already have dozens, if not hundreds, of Spring Boot applications in production today. However, business is growing, technology is evolving, and distributed teams are also changing. Companies are looking to become more agile so they can innovate and respond to change faster.
Then what should we consider to supercharge Spring Boot applications?
Thank you, Kylie. In large distributed projects, we firstly need to let each team independently build, verify, and deploy and monitor their services. Applications need to scale quickly to potentially millions of customers across the globe. We need independent services that can be scaled based on their respective demands. We also need to work more efficiently through an end-to-end development process, coding, debugging, deployment, monitoring with integrated tools and DevOps. Then we'll have a chance to achieve reliability and faster time to market. To achieve these goals, for today's show, I'm going to be a developer, and Kylie, my counterpart, is going to be in the ops team. As a developer, I'll explain how to build my services independently and run them globally.
I will see how to scale services and manage the app lifecycle efficiently. Then we will show you how to deliver value faster. Let us get started.
Microservices are a software architecture style in which applications are composed of small, independent modules that communicate with each other within well-defined API contracts. Each service is a highly decoupled building block that is small enough to implement a single functionality. Typical microservices projects consist of a collection of many of these services. Besides all the services themselves, let's discuss the other components that appear in a typical microservice component. My services need management and orchestration components. These components are responsible for placing services on nodes, identifying failures, and rebalancing services across nodes. As you can see from the diagram, we have some microservices which expose external APIs to clients. In a real-world system, this number can grow very quickly, as well as the entire system's complexity. Usually, a much better idea is to use an API gateway. We've discussed building services independently. Next, how can we run these services and applications globally? As you can see, Azure has data centers across the globe. Now I have a plan. To meet our needs, we will, 1, build cloud-native microservices, and 2, leverage off the Azure global data center footprint. Part 1 can seem difficult. I have dozens of microservices. How can I design them for the cloud? To achieve that, we're going to use Spring Cloud as our framework. Spring Cloud provides 4 key modules necessary for our microservices. Spring Cloud Gateway provides a simple yet effective way to route APIs. Spring Cloud Registry allows automatic detection of network locations for service instances. With a config server, you have the central place to manage external properties for applications. And finally, Spring Cloud Sleuth can ease debugging by providing distributed tracing. Next, let's see how backend apps can handle connecting to the many different backing resources. Instead of owning the backing service, you simply consume it. I want to use them and make my code portable. You can achieve this by using Spring-on-Azure starters. These are open source libraries by both VMware and Microsoft that further simplify connection and consumption of Azure managed services. They give developers a Spring idiomatic way to interact and consume Azure services with only a few lines of configuration and minimal code changes. Spring starters are actually part of a rich ecosystem where you can find many additional Azure Spring offerings. Let me share 2 examples there for you. The Spring Boot Starter for Cosmos DB enables developers to use Spring Boot applications that easily integrate with Azure Cosmos DB's different APIs. The Azure Key Vault can conveniently access your secrets like any externalized configurations, such as properties in files. You can get more information for each of these projects at spring.io. Enough slides. Let's show you the first part of the demo, where I start my Azure Spring Cloud project. Kylie will later jump in to show you how this project can be automated for DevOps. So the first thing I'm going to do is that I'm going to open up my terminal and leave my slides there. And then I want to actually start a cloud project. And the easiest way for me to start a cloud project is to actually go into something called the start.spring.io. And that's you can use curl to create your project structure, or alternatively, you can also go into the front end and download it. So we're gonna create. Let's go clear here. We're going to create a folder here, mkdir, and we're going to call this Spring 1 because we're at the Spring 1 conference. I'm going to go into Spring 1. Now I'm going to actually paste in my little curl, and you can see there it's going to start.spring.io. I'm going to include the dependencies of WebFlux for Reactive WebFlux, Cloud Config Client to create a config, Eureka, which is our registry, Actuator, which allows us to create health inserts for our services, Cloud Starter Sleuth, our tracing, and Zipkin, which will provide enhanced tracing and then support to make sure that we have those cloud services. I'm also going to tell it what Spring Boot version and then the Java version that we're going to do. And you'll notice that as soon as I actually go in and hit enter, it creates the project for me. Let's make that a little bit bigger there. It creates the project for me. I've got my Maven wrapper, my source files there, and everything's actually created for me. And I can go ls, because I am on a Mac, and I've got my project for me. So the first thing we want to do is make sure we've got our Git set up. So we go git init. So I'm going to push this project through to Kylie, who's going to run the project in the DevOps process. So it's initialized there. Next, I want to actually go in to my Visual Studio Code. So Visual Studio Code. So I go Code Insiders, and this is the Insiders edition, which is really, really rich in new features. And I'm going to say use the current directory. And it's going to open up my Visual Studio Code. Sometimes this does happen. I'm just going to go code, file, open, and just actually tell it that it wants to access that directory. Sometimes it doesn't work perfectly. There's Spring 1. and we want to go into, I think I actually created that in the incorrect directory. There we go, Spring One, and I've got all my folders there. So go open. It should actually have everything like that. Not, let's try that again. The law of demos actually says that this will work on the third or fourth time. So code insiders, and then we actually want to go, let's see, ls. Then we can just open that up there. Let's go quit that, make sure there's nothing running. And then we go code insiders and dot. There we go. It always works better when you actually show them that you struggle a little bit. That's what I find. And the audience always roots for you if you suffer a little bit. So now we have that working there with our insiders. You can see there that it's got the project structure. We have the main project there. And in the main project, we have a demo application. The demo application just does a run command because it's running in Spring Boot. And then we also have our POM, which is our project object model. And our POM really is exactly what we specified in the start.spring.io. But I want to actually change it a little bit because I want to test this locally on my PC and then give it to Kylie, who's going to actually test it in the cloud. So I have everything ready kind of set up with a nice little extension called snippets. It's a little bit of a secret. And I'm going to go back into my POM here, and I'm going to type in there, I want the preset up the Spring One POM. You can see here, and we also want to hit always. Now I've got a nice now little cloud profile that will do the starter config, and zip in, and add it in the cloud profile. So my POM setup. Let's go create our file. Now what we're going to create an application that is going to pull the 3 topics that we are going to do at Spring One. And it's going to pull it from a Cosmos DB database using Reactive Cosmos DB interface. And then it's going to bind it to a REST service that you can actually hit, and it's going to pull that information through there. So if I go into my demo, I'm going to go a new file. And the first thing I want to do there is create a DTO or a little POJO called event.java. The event.java is pretty simple. It basically just goes in and has a topic and an ID, and that's about it. We want now a repository that we can pull that information from. So I'm going to go new file there, and I'm going to call this event repository. It helps that if I spell them out actually. Elsa no, that's wrong. Repository, yeah, that's better. And then I'm going to actually go in there and type in their repo, and you'll see there that my event repository extends Reactive Cosmos repository. That's it. That's really everything that you need to wire the event repository. But we just need the controller. So I'm going to go there, and I'm going to go event controller.java, and I'm going to add just one REST service there. Pretty simple. Event Spring One controller, and then you'll see that it's just bound to topics there. We do need to tell it which database we're going to do. So in the beginning, I'm going to test it locally, and I'm going to just bind it to my hard-coded property. You never check these in, and you can see there I've got a URL, and Kylie's giving me all of this. And after I've tested it, I'm going to take the key vault that Kylie sent me before this and make sure that I bind it. So everything should be running right now. I'm going to go back into my application, everything's saved, and then I should be able to just go into my run command, run and debug, and it should bind to the database using the power of dependency injection automatically. You can see that it started the Tomcat. Come on, connect. Come on, connect. Let's see if it connects. And it's going to bind there and bind using Reactive Cosmos DB. And remember, we've just launched Serverless Cosmos DB. So if you want to have a look at it, have a look at Serverless Cosmos DB. It's got it there. That's great. And I'm going to open up my browser and go into the topics endpoint there. and you'll see there that everything's working. The demo gods are shining. It should actually pull 3 topics. There we go. Supercharge Spring Boot apps by Rory, Preddy, and Kylie Liang. Beautiful Spring Boot by Josh Long and Julian Dubois. And Accelerate Spring Boot apps at scale by some of our customers. But great, so that's working there. The next thing I want to do is actually go bind that to a key vault. Now, I've already added the key vault dependencies. Oh, not that. Let's just put that. I've already added the key vault dependencies in there. And all I have to do is, because this uses the idiomatic Spring Boot Azure libraries, is just type in the key vault URL, and Kylie's given it to me called Super Spring Key Vault. And then I use the key vault to actually go in, pull in the URI key and database. And I can check this in because this is secure. So let's go check that in, and then I'm going to hand over to Kylie once I check that in. And I've got all my Git commands already in one nice little bunch here. I want to just do that, clear that out, and then I'm going to just make it a little bit bigger. I've got everything checked in, and I'm just going to go git add, git commit, add the remote, and then push it to Kylie. Push. And done. The demo is done. Now we can actually hand it over to Kylie. I'm going to stop sharing my screen, and Kylie's going to take you through to the next part of the demo.
Sure, let me share my screen now. So can you see my slides? I assume yes. Okay, great. As already demonstrated, he already decoupled our applications to microservices. Let us see how to scale them based on their respective demands without impacting the overall performance. In fact, Rory already shared this concept of orchestration. Typically, this component is an off-the-shelf technology such as Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It has many of the features I'm looking for to orchestrate my microservices. As you can see in this diagram, here is a typical workflow that lists how Kubernetes rolls out work. But it seems I must know a bunch of things, like pod, scheduler, YAML, and how to operate them. Then let's try to find an easy way, as I only really wanted to focus on managing my business apps. I'm going to focus on the end-to-end lifecycle of my Spring Boot apps. Let's look at some ideas that can help me. What I'm really looking for is an approach to easily operate and manage infrastructure, Spring Cloud components, and Spring Boot applications on hundreds of instances. My main goals are to 1, set up and host a Kubernetes cluster. 2, build and host Spring Cloud's registry, configure server, and distributed tracing. 3, containerize Spring Boot applications, deploy them to the Kubernetes cluster, and while the application is up with the Spring Cloud components, then perform start, stop, scaling, and other operations to manage the application's lifecycle. Rory shared with me that there is a platform named Azure Spring Cloud that may be the one I'm looking for. Azure Spring Cloud removes the burden and the related challenges of setting up and managing Spring Cloud components and Kubernetes. It is a fully managed service for Spring Boot applications. It lets me focus on building the applications that run my business without the hassle of managing infrastructure. As you know, we have dozens of microservices. I can automate resource management and application deployment using my favorite DevOps tools. We have a big team. I can monitor the health of my applications and isolate features to some microservices using Azure Monitor and achieve authentication using Azure Active Directory. Azure Spring Cloud is integrated into Azure ecosystem and it is enterprise ready. I noticed that what I must do is to just deploy my applications. After that, my applications are automatically wired up with Spring Cloud Service Registry and Config Server. My applications can interact with any Azure or external services, such as database or cache. Besides Jar artifacts, I can directly deploy source code through the built-in VMware Tanzu build service, which creates container imagery from the source code. Tanzu build service relies on KPAC, an open source Kubernetes native build engine to automate the creation and the updating of Docker images using cloud native build packs. Build packs separate out the base image, the runtime, and the applications into different layers, and they are very quick to update only the layers that change. While KPAC and cloud native build packs are not exposed to users, I can rest assured that Azure Spring Cloud is running them for me. I'm going to show its magic here. As you have seen, you only need to tap one command line to trigger it, then to get your source code containerized and up. And you will love this one. With the out-of-box support of Azure Monitor, I can easily visualize how applications are performing. I can isolate potential problems to individual services. I can set alert rules for some important conditions. I can also identify and address issues before our end user notice them. Then let's look at a summary of all the features that will allow us to focus on time to market and working in distributed teams. As you can see in this summary, I think I have found the platform to supercharge our Spring Boot applications and deliver features to the market faster. It's going to let Rory and I focus on application iteration and debugging, and then let the platform manage all the other responsibilities.
Great. Can we use it in production today?
Good question. Yes. As I just learned from the keynote of Spring 1, it is generally available now. Yeah, I'm so excited to show a demo here to see how we can take Rory's application and host it on Azure Spring Cloud. Now that I will go to my demo, and you can see this picture from my screen. Before my demo, I already created Azure Spring Cloud service. And you can see it is very straightforward. You just need to specify the name and the region. And I also enabled diagnostic settings and tracing, which will be used in my demo later. Okay, let us see what happened after Rory checked in his code. So after Rory checked in his code, it triggered the CI/CD pipeline I set up with GitHub Actions. Then it will build those projects with Maven, and it will deploy applications to Azure Spring Cloud. So you could see there are two applications here. One is event service from Rory, and I also got another project named Gateway from the other developer. Let me show you how it works. Once you commit any new code, that will trigger this pipeline. And then it will build the projects with Maven. It will log in Azure and then deploy applications. In general, as you know, once we have a new version, we will not directly deploy that to production environment. We will put that into staging environment and see whether it works or not. So here you could see I added a permit, deployment here. So I will deploy these two applications to my green deployment instead of the default one, which is already used by my production environment. Okay, let me show you how that works. So from this page, you could see two applications, event service and gateway. And each one have two deployments, one for production, the other for staging. So we just got green deployments built out from our GitHub actions. So let us have a try. For each application, I got one test endpoint. So let me access this test endpoint and the topics. Great, it works. And since I added the gateway in front of that, then let me also try my gateway to see, whether that works or not. The same, click that, then you can get the test endpoint. Okay, so you can test this one, and let me also show you in production environment, we also then the public endpoint. So you also could directly access this public endpoint. Let us try this one and show how that works. Okay, so that is how the gateway works. So you can see I have two applications, and I then two instances for my gateway app, but only one for my event service. I wanted to ensure I have enough app instances to host my event service once there are more traffic. Okay, how to do that? Let me define some rule to trigger auto-scaling. It is very easy to do. Okay. Oh, before that, I forgot to do one more thing. Since we already validated green deployment, right? So we have confidence to switch my green deployment to production environment. Let me do that first. Okay, then I will go back to deployment. That is very easy, very quick. Just select the application, event service here, and click button. Okay, I want to use the new version created by Rory and apply that. 1, 2, okay, 2 seconds, that works. Then let's go to the production environment and go to scale out, select the green deployment, okay, this one. Okay, you can see there are two approaches. Okay, one is you can define the number manually, and we also can define some rules to trigger auto-scaling. There are two dimensions. One is scale based on a matrix. And you also could create another one, okay, to trigger scaling based on schedule. Today, I will show you how to define the rule based on the matrix here. Let me add a rule. Okay, I will use Tomcat request count. Okay, this one. Okay. Okay, if the count is greater than 70, let us increase the count by 1. is that, let me add that. And I need to save that. Okay, once it is done, I will run some test scripts to generate some traffic to validate that. By the way, you also could get all notifications from here. That is still running. Let me try to refresh the page. Azure Monitor have some issue here. Let me try that again to ensure I really saved this rule here. Okay, I have this rule. Let me double check. Okay, number one, update, and save that again to ensure I really got this one before my next step. Okay, it works. Okay, let me go back to overview. And we also could track the request number here. I already opened my Linux test machine. And let me go to run my test script here. Okay, it will generate some metrics. I will also trigger this one from my local Windows machine. It will take minutes. So since we need to wait for that, why don't let me introduce some exciting features here. Yeah, in Rory's demo, he directly used keyword URI in his application.properties. Then, how does it work? So firstly, you can store your credentials in Azure Keyword. Then next, how to get your application access that Azure Keyword. So this is supported by Azure Managed Identity. So I enabled this identity for my event service, and then I grant access to my Azure Keyword. Just these two steps. Then that is a magic for Rory's demo. With that, you don't need to store any credential in your code. Okay, that is the first thing I want to share. And secondly, I want to show you how easy to monitor Azure Spring Cloud applications. I will cover metrics, logs, and tracing here. So I have two microservices. So firstly, you could choose different metrics, including error, performance, request number. Let me just check maybe CPU usage like that. As I mentioned, we have two. So I want to see what's going on for each one. So you could add splitting. Okay, there are three dimensions per app, per deployment, or per instance. So I could see the metrics for different applications. Imagine if I have 100 microservices. I really don't want to see all of them in this table. How could I do? You could add a filter and select what app you want to see. Okay, it is easy. Have a try. Then let me show logs to you. Here you could define the query to see how what kind of logs you want to check. If you are new for this one, don't worry. We have examples here. So let me just select one. So that will check all logs that contains error or exceptions. So you could see the app number, and you also could see the logs. So you could click that and check all details there. Of course, you also could edit your query. For example, I have two applications, then I could specify my application name equal to gateway here. So that's for log. Lastly, let me also show you the distributed tracing. you could check out the application map. You will see 2 microservices here, and you also could see the relationship between these 2 applications. And it also will show the performance status here. Okay, if you meet some performance issue or have some performance bottleneck, you may see the red part here. Then you could click that and get more details and do further investigation. Okay, I hope you like those monitoring features. Then let us go back to see how's going on for our scaling. Yeah, the metrics is up. I think that also will take a bit time. Meanwhile, let me double check my auto scaling rule here. That is for migrating deployment. Yes. And increase count by 1. Yes. Okay. Then let's give it some time. Then in general, after that, you should see, okay, I have number 2. I will have 2 instances here. Okay, that will take some time. I may come back to show that again. And let us you see the magic later after I completed the slides. So let me come back to our slides here. Okay, so we already have showed you how easy it is to collaborate between dev and ops. Rory and I will continue to share the roadmap as Java Cloud Advocate and the Program Manager here. We already demonstrated how to get secrets from Azure Keyword for applications running on Azure Spring Cloud and auto-scale them. One more feature I wanted to highlight is VNet, Virtual Private Networking. With it, you can achieve isolation of applications from the internet and enable hybrid cloud scenarios. For example, you can connect cloud-based applications to any type of on-premise system, such as a database. And in the upcoming months, we will release more security-related features to protect your app and data, more capabilities to monitor your applications, as well as tools to simplify your daily work.
How can we provide feedback to the product?
Yes, thank you for asking. In fact, you can help us ship this feature and this service. Scan this survey. Tell us how you think and what you want. By GA, we have enabled 10 regions for your global applications needs. More are upcoming. You name it.
We also have news for the Spring Azure ecosystem. Our goal in the upcoming 6 months is to enhance these Spring modules and bring them on par with the best of breed Spring implementations for Spring MVC, Spring configuration, and Spring data. We will ensure better compatibility through the integration with the Azure SDK pipeline. Also look out for these new features. Search your resources with Azure Storage. Load secrets from multiple key vaults. Integrate with Microsoft 365 API through Azure Active Directory. We also have some great links to resources to help you get started. First, use your existing Azure account to start with Azure Spring Cloud today and leverage the expertly maintained Microsoft Doc references. Then integrate with Azure Spring starters into your projects to introduce Spring idiomatic Azure libraries. And finally, spend some quality time with our workshops to get detailed experience with Azure Spring Cloud. Also, don't forget to miss the 2 other sessions by Microsoft, Accelerated Spring Cloud Apps and Beautiful Spring Boot. Thank you. Thank you for your time, and we'll take questions, and we'll be in the Slack channel to take your questions.
Yeah, thank you. And please also allow me
Rory,
come back
Kylie, thank you
and
so
to
much
share
for joining us. I really appreciate it. And for those of you that want more of this conversation, please click the join the discussion link and head on over to the Zoom Q&A room, where we have the proverbial virtual hallway track where you can continue to ask questions, get more feedback. And with that, we're going to have a little bit of a break here. Get up, stretch your legs, grab a snack, grab some more coffee, or if it's in the evening, maybe an adult beverage of your choice. But stick around, because the man, the myth, the legend, Matt Rabel, is up next talking about security patterns in microservice architectures. Imagine that, security. It's an important concept, right? All right, so let's go ahead and take a break, and we will see you guys shortly for Mr. Rabel.